The SSF model of instructional design was designed for the teacher or instructional designer to develop a working structure of the auditory events with the primary purpose of helping students to control their attention in multimedia. According to the SSF model, 5 functions are conceptualized for sound as descriptions of character, place, time, subject matter when assigned to a visual event displayed in multimedia. Let's look at each of these. Temporal sound. Temporal sound is an alert, a caution, a warning, a direction about a future event, or a reminder about a past event that is displayed as a visual event in a computer program or internet site. Some examples of temporal sound cueing include instruction, navigational directions, hinting, feedback, and reminders. Point of view sound. Point of view sound describes a particular perspective towards adding sound to help learning from multimedia. When an objective, subjective, or performer point of view is presented in sound, it can imply another point of view or more information about the point of view than what was stated or implied in the visual event. Alternatively, a point of view sound can be prescribed within a character's personality, showing internal conflict between objective, subjective, and performer points of view. Point of view sound can also be made to differing opinions about political performers or deeply felt moral, cultural, or religious beliefs. Locale sound. Locale sound can fill an informational role when it is associated with a visual event presented in a video clip, graphic, or a paragraph of formatted text. Most often, familiar sounds are added to establish a place, real or imaginary. Locale sound in public spaces can transform a passive experience into an active one through an earpiece. Mobile technology can offer users in a city or historic site or at a public event a more comprehensive understanding of their surroundings. Atmosphere sound. Atmosphere sound can provide the context for an event for the listener-viewer in the absence of visual information. A broadcast journalist using streaming technology over the internet can, for example, verbally provide an eyewitness account of a scene after the fact. Similarly, a voiceover plus a map or photo of the speaker will suffice in lieu of visual evidence of the event. Atmosphere sound can also provide a feeling about a human condition. Still, other times, atmosphere sound can set a mood, or in a celebration or political meeting, atmosphere sound can easily be misused as well by manipulating the structure of the sound-visual relationship. In a major CD project, for example, where a range of sounds were integrated as the students navigated the information, a student made a choice to see more detail about Thailand, and a short musical track was played. The student commented that the sound was not Thai music and decided that the remaining information would not be useful. Juxtaposing inappropriate music or laughter over a visual event, therefore, can undermine the original intent. Character sound. A character sound refers either to a character's past, their future, or their personality, real or virtual. Personality sound refers to the subtext, the story spine, or tragic flaw in a character. Like personality sound, the character's past or future sound contains auditory references to the character's personal, private, or public event or idea. Unlike personality sound, however, this function does not plumb the depths of the character's psyche. SSF research with graduate students and pre-service teachers learning instructional design, 7th graders learning fractions, 7th graders learning combustion in a chamber, 4th and 5th graders learning grammar has been promising. Under most conditions, the long-standing need described in the literature for purposeful advice on how to enhance multimedia learning can be met with this model. The SSF model is based on the attentional control definition of multimedia learning. The attentional control theory originated from reviews of the research in several disciplines that developed independently of one another, despite their common field of study. Two of the most important influences are the general model of working memory and the supervisory attentional subsystem model. Although influences do not target multimedia learning directly, they explain why sound is so critical to multimedia learning. According to these cognitive theories, sound is permitted direct access to the student's phonological store. Taken together, the attentional control definition and the SSF model provide mutual support between the psychological description and the educational design, analogous to a two-way street, as we said before. Standard position of multimedia learning research on the SSF model, and coincidentally the attentional control theory of multimedia learning, on which the model is based, is a departure from the standard position on multimedia learning research. Whereas the standard position of learning for multimedia has advanced our understanding about its impact on adults and provided an alternative to media comparison research, there are shortcomings that reduce its applicability in education. First, the standard position of multimedia learning research is based on experimental studies with adults, mostly undergraduate psychology majors, not children. Learning for young children is different from learning from adults. Young children are not simply little adults. And therefore, claims about media effects based on the standard position in multimedia learning should be constrained to learning in adults. Second, instead of studying multimedia learning over several days or weeks, as in the attentional control theory of multimedia learning, the standard approach has relied on impact studies, testing immediately following the treatment. Consequently, educational benefits of the standard position are not as apparent as they could have been had the research used delayed post-testing to examine learning effects over a period of time. In accordance with Sweller's view, for example, that the main purpose of instruction is to build knowledge in long-term memory. Third, although there is an ongoing initiative to investigate quantitative effects of offloading and weeding details from visual events and of increasing signals in sound, the instructional designer may still be left guessing how much and how often to use sound and how much detail to leave in text, the graphic or animation. In summation, then, the purpose of the SSF model of instructional design is to design the modality of instruction for learning. Let's take a moment to look again at this model. These slides talk about, well, LTM stands for long-term memory, but this model deals with multimedia learning in children and in adults. This slide shows a kind of job aid for the multimedia designer, particularly for educational purposes, where they can combine along the left side going down the functions of sound, as we've talked about, the temporal sound, point of view sound, and so on, with the structures of sound throughout the entire computer program or video clip or whatever across the top.